So when I submitted my CFP, the call for papers or call for talk CFT, I think it was, for this con, I had to come up with some kind of a fun title for my talk that was going to draw in a nice big crowd like you all. So thank you for coming. Basically, we're going to be talking about code review and how we can leverage AI to help us with code review. I mean, right now, AI is like over half, I think, of the talks today and tomorrow. Like, AI is in the title somewhere, right? So it's like everywhere. But we really need to consider, even though it can be everywhere, really should it be? How can we, what does it bring to the table? You know, what is it actually helping us with? How many companies have you heard of or that you work for that have tried some level of AI adoption and it's just creating more work than it's worth, right? It's not actually creating value. So maybe a little adult supervision is needed here. So let's look at what this looks like. So I gave way too long of a bio to last con, apparently, because I didn't realize they were going to be reading them all out loud. So here's a shorter, condensed version. I was born and raised in Hawaii. I've been tinkering with computers since, before I was old enough to drive. I actually started even before BASIC at 9. I learned Logo in school on one of the Apple. I don't remember if it was an Apple IIe or what it was, but I remember teaching that turtle to go navigate around the maze, and then later on how to use the pen and draw like all these fun little circles and make these fun little shapes and stuff. So I was hooked. I was hooked from age 6. So I have always been in technology. My first computer was in an Atari 800. Does anyone know that Atari made computers, not just video game consoles? So the Atari 800, my mom found at a garage sale in the 80s with a BASIC interpreter cartridge. That's all it came with, was the BASIC interpreter. If I wanted to learn how to use this thing, I had to learn BASIC. So I got a book and I learned BASIC. Later on, I heard that BASIC isn't really great for doing more advanced things, and I heard about this thing called C, and I knew that some of the video games I like to play on my computer, so we had moved to a 286 by this point in time. My mom, it was a 12 megahertz, so not super turbo, 640K RAM, because you'd never need more than 640K RAM, right? Exactly right. I'm old MFM drive, so yeah, that's the world that I grew up in. I know I got a baby face. Most people don't realize I have a 21-year-old. But my 12th birthday, I asked my mom to buy me a C compiler because I heard that was really where the cool kids were coding. So 16-bit MS-DOS C compiler I still own on my 5.25-inch floppy disks. Thank you. Some people played sports as kids. I tried to make my computer beep in interesting ways. So that's where I came from. When I started playing more games on my computer, I discovered, hey, I save my games into files that I can access. Does anybody remember debug.com for MS-DOS? Man, I learned how to read hex so fast through debug.com. And went in and started modifying, reverse engineering the different values in my save game files, and my mind was just blown. So then moving on into my teen years, we're talking mid-90s, early mid-90s here. Before they were called CTFs, there were some organizations that were going online. I don't know, anyone remember Cyber Army? This is like really, really old stuff. But they had a long list of challenges. They called the Zebulon challenges. And you'd go in and first off, it was just real simple. Go in and figure out how to get cross-site scripting, not cross-site scripting, how to break the JavaScript login page. There wasn't anything called cross-site scripting yet at that point in time. Then there was Java applets. Anyone wrote a Java applet? 3 people, 4 people, 5 people, okay. So we don't use Java applets anymore, but that was a fun exercise. Download that Java applet, decompile it, reverse engineer it, figure out all the logic in there, figure out how to bypass all of the protections that Java applet was providing. So that's the kind of stuff that I like doing. Moving ahead a little bit, Marine Corps, I was in signals intelligence. So I was one of those secret squirrels that got locked into a room with no windows, and they didn't let me see the light of day hardly ever. But it did teach me a lot of things. It gave me more disciplined approaches to intelligence analysis that I could then leverage in my cybersecurity career. And so since then, I've done development, I've done pen testing, and right now I'm at Amazon where I teach AppSec to our certifier program, a number of students in the three and a half years that I've been there. Probably taught around 1,500 students so far. I teach code review and security testing, and it is a blast. So I also have 3 degrees, over a dozen certifications. I don't think any of that actually matters, because I think the most important thing is not how you got your knowledge. I think the most important thing is curiosity. Nothing beats hands-on curiosity. And so that's who am I. So we're talking about AI. This is everywhere. If you've opened up your IDE lately, you're using Copilot or something like that, or whether you're using the chat feature of it or the autocomplete portions of it, it's whispering these suggestions in your ear like some kind of a clingy ex, right? You should go over there and do this. Unfortunately, with the prevalence of AI, so comes AI slop. We have a lot of that. And if you came from the great talk by Jim two sessions ago, he showed a hands-on live demo of generating code that had all kinds of horrible vulnerabilities in it, which is great. I love Jim. The style that he aspires to, doing some hands-on demo, is also what I'm aspiring to do here. So in a minute, I'll be swapping out of the slides. I actually hate slide decks. I try to get through them as quickly as possible. They're kind of a necessary evil. I'm also not a front-end engineer. I've never done front-end, so forgive my color scheme if it's hard to read and hard to see. Anyway, we're good. So the AI hallucinates, there's slop. How can we find the needle in the haystack that's actually worth keeping out of all of this? That's part of what we're going to talk about here. Now, why bother? If it's not bringing value to the table, I tried AI, and I had it write some code, and it had these terrible vulnerabilities, and it took me longer to debug and get the vulnerabilities out of that code than if I had just started and written it by hand. So why bother, right? Well, in the context of code reviews, there's something that I like to consider, and I'd like you to consider. Do you spend more time writing code, or do you spend more time reading code?
I feel like I spend more time thinking about systems, honestly.
Thinking about systems? OK, fair.
I think the writing of the code is actually very minimal in comparison.
OK, so the writing of the code is minimal. Would you say you read code more often than you write code?
No.
You don't?
I feel like I think about systems way more than I do those things.
Oh, OK.
I may think about systems by reading code. That's true.
Well, there you go. You think about systems and the existing systems by reading through the code and trying to detangle all the pieces, right?
Yeah.
So I firmly believe that we spend more time reading code, and it's a completely separate skill from writing code. You can write code, and then you go back and you try to read what you wrote, a couple months down the road, and it's all Greek, right? So code reviews. If you're in an organization that has some sort of a security process that's required before you can launch to prod, code review is often a big part of that, right? What percentage of time, any volunteers here, what percentage of time does the code review take out of that process compared to the rest of it? Any volunteers?
Less than 5%.
Less than 5%, that fast?
That's pretty good.
Wow. Any others? What, do you use tools to help?
Oh no, I think people don't do code reviews.
Oh, okay. So we didn't mention quality here. We didn't mention quality. So the code reviews are only taking about 5% of the time because people don't want to do them, because it is a lot of work, and it is like I said, I believe it's a completely different skill from writing code. Reading someone else's code, understanding it, finding vulnerabilities in that code, that is a whole new skill set that a lot of people are not confident that they can actually do well. And so they try to skip it, find other ways around it. Just use SAST, right? SAST will solve all of our problems. It has already, right? So instead of spending all the time reviewing every line of code, which I don't think we should do. We don't have the time to do that. If you have security personnel in your teams or as a separate organization, separate team, whatever, however you're partnering with AppSec, they don't have time to go through line by line every single repo, every single release of every single feature, right? There's no time. And they shouldn't do line by line review. They shouldn't. That's the responsibility of the app team. So what should developers, or what should the AppSec people do? Focus on the areas where the mistakes actually cost you. Where are your auth issues? What's your crypto doing? Are you doing data validation, right? Anything that touches what I like to call the crown jewels of the application. That's where we should be spending our time. We're not supposed to be going in there and reading every single line to figure out what's going on here. So if we can use AI to do that, but do it faster without lowering the quality of the review, then I think that's a win. But you do have to be really careful to make sure you do it right. So there's a different things that we each bring to the table, right? Humans understand intent. I have one of my teammates over here, Gusti. Thanks for coming. But he knows, he's attended multiple of my trainings. I harp on this in our training. Developer's intent is everything. When you're trying to read a code base that you're unfamiliar with and you need to know what's going on, what did the developer intend to do with that code they wrote? It may or may not match what they actually wrote, right? So understanding the intent is key to discovering bugs and vulnerabilities in the code. And humans are way better at figuring out that intent. I mean, worst case scenario, I can pop up Slack and say, hey, dude, what were you trying to do here, right? Hope, as long as the developer's still available. So business logic flaws. We've had automated tooling of all sorts. SAST has been terrible at finding business logic flaws, right? AI is really maybe a step up from that. It's not there yet. Maybe it'll get there. Maybe with more of the deep reasoning models as they improve, maybe they'll get to the business logic part. But so far, my experience is that LLMs are terrible at spotting business logic flaws. And then finally, just plain old common sense. Why isn't common sense part of the data set that all these models get trained on? I don't know. How do you distill common sense into a data set so that we can actually get that in our AI? Anyway, what does the AI bring to the table then? That's what the humans bring to the table. What does the AI bring? They're very, very fast. They're super fast idiots, right? That's what we call the computers in the first place. They can do math on ones and zeros blazingly fast. OK, great. So AIs are also very fast. They're great at summarizing. You know, they're built on language. And so taking this much language and condensing it down to like this much language, they're pretty good at that. And then they also have oftentimes broader knowledge than the user. So I spent most of my career in, even though I've dabbled in probably 3 or 4 dozen different languages, just because I find that fun. I know my brain's weird. We won't go into all that, but I've only used probably 4 or 5 professionally. So that's not a lot, but even that is more than some people have done, right? Anyone here has been a full-time front-end engineer and you've never touched anything but JavaScript? No? OK, so sometimes there's at least one, but not today. Usually people have a pocket full of things they're comfortable with. So what if you are called on to review an application that uses a different framework or a different language than you're familiar with? Believe it or not, LLMs are pretty good at understanding that because it's in their training data. And so helping explain those types of things to you. So that's where they can help. So what does my code review process look like? This is something that I think works. If you have your own process, think about how it compares, and I'd love to hear your ideas. But when I do a manual review, I always start by performing a mini threat model in my head. And this is how I figure out what the threat model is. I have to understand what is the business purpose. What is the code trying to achieve? What are the different use cases? Who are all the actors involved? What business value is this bringing? Then I want to identify the crown jewels. So what is in this application that from an attacker's point of view is the most valuable? Those are my crown jewels. Maybe it's not user data. Maybe it's access to other systems. Maybe there's something else in my application that is valuable to an attacker that I don't maybe think about as a builder. As a builder, I think, oh, I've got my PII, I've got my credentials store, I've got different things that might be of value to me as a builder, and I don't always think about from an attacker's perspective. But really, when I'm doing the code review, I want to shift my mindset. And I want to think from an attacker's point of view, what are the crown jewels? Then I'm going to look at my attack surfaces. I want to identify every way into my system. Then from those attack surfaces, where does that data flow? Where does it get processed? Where does it go from there? And by tracing those data flows source to sink, if they cross the path of any of those crown jewels, that's where I want to spend my time. I don't have time to go line by line. So I only want to spend my time on that 5–10% of the code that actually matters from a security perspective. So this helps me triage more quickly. So what does my process look like when I use AI? So here you can see that my approach is completely different. It's just drastically different from the last slide, right?
Yeah.
It's drastically different from the last slide. I mean, OK, so I'm just kidding, right? My AI-assisted process is exactly the same. I'm not doing anything different. I'm not handing off work that I'm just going to let the AI go and do. Maybe to some extent I'm letting it do the work, but I'm always supervising it. So same steps, same logic. The difference is that the AI is helping me move faster. It's helping me go from hours to minutes. It's helping me summarize large chunks. It's helping me identify things that maybe I would have missed manually, and helping me identify those pain points that I want to focus on and say, hey, this is where my crown jewels are at risk, and I want to go look over here. So the AI doesn't help you skip steps or replace any of the steps. It just helps you go through them faster. And this is why a lot of these things fail when companies try to adopt AI. They're trying to replace people. They're trying to replace skill. AI does not replace skill. They want AI to be some sort of automated automation. So we had automation, and that wasn't good enough. Now we want to automate our automations by telling the AI, go build an automation for me. And then we're just going to trust it? No way. So the AI is supposed to go build up all the infrastructure, all of the logic on how it's supposed to work. Vibe coding is great, but Vibe AppSec is just not a thing. I know that might be a little controversial with some of the vendors here, but Vibe AppSec is just not a thing that should ever really exist at this point. You can't outsource that human judgment that is so critical and still needed right now. If you're a junior engineer and you don't know what insecure deserialization looks like, the last talk in here was talking about Pickle and the vulnerabilities that can bring to LLMs. If you've never seen how to get remote code execution from deserializing an unsafe pickle file or pickle object, you're a junior engineer and you've never seen that, you've never heard of that before, then AI is not really going to save you here. I've actually seen one of the great things, and I'll talk about this a little bit more when I talk about things I've seen in the class, but the hallucinations, I always do live demos in every class that I teach because I think that is the most impactful, and I like people to go work alongside me and they get that actual hands-on. So it hasn't failed yet. Since I have added in the AI to my course, we've had hallucinations every single time. Over months of progress of the different models. How many different updates to Anthropic Claude, into ChatGPT, into Gemini, and it's blazingly fast how quickly they're releasing updates to the models. Even with all of these updates, we're still getting hallucinations. So the LLMs do not replace the skill. And so, yeah, hallucinations. This is actually good news, though, because when I'm able to catch the AI hallucinating something in the middle of a live demo, that just really drives home that fact that you can't let them go without human oversight anymore, or at all. You can't take humans out of the loop. You have to have a human in the loop. So in my classes, I strongly emphasize the fact that we are partners with the dev teams. I was a full-time developer myself before I transitioned over into AppSec. So I have a heart for development teams. I hate to see that culture clash where the devs think security is just trying to prevent us, slow us down. I try and do my best from the AppSec side to say, no, if you are working in security, your job is to make the devs' job easier, to help them release secure code faster. That's what we're here for. We should be building tools, we should be building processes, taking out all the cruft that slows things down. It's really important to build that trust. For me, that is core to what I do, building trust with the app teams. If we give them reports with false positives in it, or AI hallucinations, and they go and they trace down what we claim is a vulnerability, all that work, all that time and effort, all that relationship building goes down the drain. Are they going to trust you again? It's going to take a lot to earn back that trust. Initially, it can be easy to build trust. When you break that trust, it is exponentially harder to earn it back, right? That's just human nature. We're risk averse. So we don't want to breach that trust. And so we want to be very careful about the hallucinations. And remember, AI's confidence level is not a measure of whether it's correct or not, because it's always so sure of itself. So this is the simple rule. You trust but verify. Every AI output has to have a human sanity check. Just like if you were a senior dev or analyst or engineer overseeing a junior. You're going to give them a task, you're going to have them do the work, and you're going to double check it to make sure that it's good before you go and push the code changes or whatever. I believe that trust has to be earned, and frankly, AI has not earned my trust yet. AI is going to be an assistant, not an authority. So we do want to set the right expectations here. Once again, this doesn't mean that AI is useless. It just means we need to have the right expectations going into all of this. If you use it wisely, you can finish faster, or this is kind of an either or here, or you can cover more ground. Most of the time, code review is time constrained. All security reviews are time constrained. The business needs to launch. The users are waiting for their feature. They're not going to go and pay for the upgrade or pay the subscription or whatever if you're not releasing the features as they expect. And so we have to work within the windows of finance, right? That's what we're doing. If you want to go faster, you can use AI to go faster. If you want more coverage, you can also get more coverage, but you can't do both at the same time. So figure out which one's more important to you. I would say you generally can't do both at the same time. It's one or the other. But this is, either way, this is still a real advantage. And once again, it doesn't replace the need for having junior analysts or junior engineers. It becomes a force multiplier, whatever your skill level is. So if you learn AI on top of whatever it is, then it augments you. Now, some technical considerations with all of this. I mean, it sounds great, right? Let's throw this whole code base at the AI, and we're going to let it analyze it. We're going to use it to help summarize things and help direct us to where we want to spend our human attention to find the vulnerabilities. But the context window, we can't throw that whole thing in most of the models. There are some like Gemini that has like 1,000,000 token context window. But even those models with the larger context windows have trouble paying attention to everything in that window. And so it loses focus. The bigger that context window is, the harder it is for the LLM to pay attention to what's actually important. So this is why we've gone kind of from prompt engineering. You've probably heard about context engineering, where you're trying to mold the context, give it all of what it needs, but only what it needs. And so context window limitations are an issue with the process that I use as well. We need smarter ways to kind of chunk things out and analyze the code here. So one solution is using subagents. And this is kind of what I was doing before. You figure out which agent should be focused on which part of the code base or which modules or which particular vulnerabilities. Tell this one to go look for one type of vulnerability, this to look at another. There's different ways to chunk that out. But then you have some sort of a manager that aggregates everything back in, combines the results. And I was doing this just through raw prompts before and having it track things in markdown files. But a little surprise for you, this past Tuesday after work, I decided to sit down and learn how Claude skills work. So I use Claude Code at home all the time. I use Amazon Q Dev at work because I work at Amazon. They both use Anthropic's Claude model behind the scenes. But when I'm working on personal projects at home, I use Claude Code from the CLI. And I had never actually built a Claude skill. So I thought, you know, this would be interesting and fun. So I built a skill that handles the context intelligently, chunks things out, hands it off to different places, merges the summaries. And it's actually pretty great. I'm going to do a live demo of that right now. So let's switch over and see what this actually looks like. And I got about 20 minutes here. So hopefully this will help that light bulb moment where you can see everything fit together, OK? So here we are. And I'm going to do a quick git clone of the repo, GitHub. And this is an old app that I started working on when I was first playing around with vibe coding in February of this year. I was building this DocVault app in Python. And we're going to go into DocVault, and we're going to quickly make a Claude skills directory. We're going to go into that Claude skills directory. And then we are going to git clone. Is the text big enough for you to read? Or do I need to make this bigger? Little larger? Let me see if I can.
Probably double its size. There you go.
Is that better?
Much better.
OK, apologize for that. I'm going to clone the skill. It's just called, wow. What did I name it? I know, it's just sec review, just sec review. There we go. OK, now I can go back to my main directory here, open up Claude Code. OK, and now all I have to do is sec review and the current directory. And my brand new skill is off and running. This is how easy it is to install and everything. It's MIT licensed. You can go. I have a link to the thing to the repo at the end of the presentation here. But you can see it's going to go and create a number of things for me. I should have just given it access to do everything. I don't have time to let this all run. When I ran this, it took about 9 hours total. It burned a lot of tokens. This is alpha quality because I just built it. I haven't done any tweaking to the prompts that are being used at each stage, okay? So it burns through a lot of tokens. I'm on the Claude Pro plan, and I ran into my token limit twice before it completed this review. So it's not something what you want to necessarily use as is. But just like on all the best cooking shows, I have it pre-baked. Okay? So here's the actual output. Like I said, it took about 10 hours total running over, and the code base is not all that big. There's a lot of tweaking I need to do on the prompts. It's doing the same steps in multiple stages where it doesn't belong. So again, I apologize. It's not fully ready, but I wanted to share it anyway. OK, let me make this bigger. So this is doing a code review. You can see it's looking at everything that's used. It creates a number of markdown files based off of what it finds. And you can see here it's asking for an AI model. It actually will let you pick if you want to use OpenAI or Gemini or something else instead of Claude. You can do that as well. Like I said, if you have a really big code base, sometimes the models with the larger context windows might work better for some of this analysis. So you can see it's doing those steps that I listed before. What's the business context? OK. What are the assets? Right? Asset identification. Let's keep going here. What does the attack surface look like? And at each of these stages, I'm having it write markdown files to track what it finds, and it's feeding in to the next stage. So it can use the output from the last stage as it's doing the next. OK, then it's doing that data flow, source to sink. Where is it going? And then where does it cross the boundaries or intercept the actual crown jewels? And then at the very end, we're writing a really big report. Report generation. All right, so that's what it looks like. And this is the output. And I happen to have that output over here in VS Code, so you can see kind of what it looks like when you're actually using an AI to help you go through these different phases. Once again, at each stage, when it's done figuring out that business context, you, the human, your responsibility, go in, make sure this is actually correct, because it's going to hallucinate things. And if you just feed this into the next stage, those hallucinations are going to propagate, and you're going to end up with a mess of unusable slop at the very end. So by doing this stage by stage, pausing, letting the human come in and review and modify and correct, and then letting it go and move into the next stage, we are actually saving a lot of time overall. The amount of time it takes to review the output of the LLM is less than it takes to go and do all of this yourself, usually. So let's go to the top of this report here.
Have you had a lot of really good success with correcting the AI slop? Like, you say you need to check this and correct it, right? I find that when I have code and I'm producing code, even with corrections, it still is just stuck on the last thing it was doing anyways, if I tell it to continue. How did you get around that?
Clear context each time. So this is a benefit of using subagents. When you're having one long session, once it already has it in its mind, hey, I generated the code this way the last time, even if you tell it, no, that's not right, that's still in the context window. And that still can confuse it. So this is part of that whole context engineering thing that's become a fashionable term these days. You want to clear out the cruft from that old context that's causing it to repeat the same pattern and get it to do it over.
So akin to making a new chat that doesn't have
Right.
any memories of its last chat.
Right, right. So this is the business context. You can see here it's got a nice little summary. It talks about the functionality here. This is what it does. It aggregates all types of information for me, keeps it in one place. It's kind of like a scraper. So the reason that I built this in the first place, and I don't recommend anyone actually go in and try and use this. It's abandoned. This is an abandoned thing. But I was trying to vibe code, and as everyone that's done some vibe coding has run into, the model library, the models that the library versions that the models were trained on are not current most of the time, right? So it's trying to use outdated libraries that maybe have some CVEs or something that you want to avoid that. So I was trying to find a way, how do I pull in current documentation for a library that it was trained on already? Or how do I pull in documentation for a model it was never trained on at all? And how can I provide that back to the AI? So that's why I built DocVault. But again, don't actually use it. It's been abandoned for months. But it does make a great demo here where you can see how it actually figured out everything without me telling it anything other than go look at the repo, read through the code, read through the documentation that's available there. It did a really good job on the context. Then identifying the assets. You can see here, it identified that, hey, there's some API credentials because I use things like, I have a Brave search key that I use for doing some of the web scraping. And it correctly identified there's not 47 critical assets. I wouldn't even say, I didn't go in and fix all of this. There's probably 20 or so of these assets that are legitimately sensitive. But I don't have the time to go through all of this, just kind of give you an idea of what kinds of things to expect. So here's where it did the attack surface enumeration. Let's get to the top of this file. And correctly determined that there's two primary attack surfaces. There's a CLI. There was also an MCP server that I built. It correctly identified that the MCP server could run using standard I/O or also using the now outdated SSE, and correctly determined that there is no authentication there on the MCP with SSE, which is a huge security issue. It also correctly determined that that is the most critical finding. So I was actually pleased to see this. But if you could go down further, you can see it enumerates actually all of the different entry points, all the commands. It even found where I had implemented backing up the vault to a zip file and then restoring the vault. And the fact that, hey, I hadn't considered that you could have a zip bomb type of attack, right? If I was trying to restore someone else's vault to mine, I didn't think about that actually. So this was kind of helpful. Even though I'm not going to maintain this anymore, it was still informative. Data flows here. So it identified 10 critical data flows, and again, yeah, most of those are through the insecure MCP server, which I knew about because it was never really. It wasn't designed at first to be used by anyone but me. It wasn't really supposed to be multi-user. So that was just kind of a hacked-on thing at the end. It did give me some props. I was a little bit proud of this. You know, I'm an AppSec practitioner. I have a software dev background. So as I was building it, I was actually, if you attended Jim's talk where he showed you how to build out those secure prompts or the different types of prompts to build secure code while you're doing your so-called vibe coding, I would say that's not really vibe coding anymore, by the way. That's correctly using the AI to write code. But I actually did. Well, I actually did a lot of the same things when I was building this, and so I built it in, you know, with the idea, hey, I know there's going to be SQL injection vulnerabilities. I know that there's going to be path traversal. I know that I'm basically providing SSRF here. And it termed this in the actual executive report later on. It calls it SSRF as a service. It's great. My app is SSRF as a service. I thought that was hilarious. So it has an unintentional sense of humor here. And also coming from the old DOS days. Anyone play with ANSI escape sequences in DOS? Yeah, you know some of the things that you can do with ANSI escape sequences? It's kind of fun, like redefining your keyboard. I actually use that for real purposes. Anyone here played online games called MUDs, those text-based games? So when I was playing MUDs in the 90s, you know, I would want to have keyboard macros. How do you do keyboard macros in DOS? I didn't want to go buy some expensive TSR software to go and do macros for me. I just used ANSI escape sequences and redefined keys on my keyboard to go and run a whole bunch of commands for me. Did you know you can use that maliciously? You know someone that might have gotten locked out of the lab, kicked out of the college computer lab because I played a prank on someone? Yeah, I almost failed that year because I couldn't go write up my papers and finals because I got kicked from the lab. Anyway, you can do some fun things with ANSI escape sequences. So I had that in there too. Okay, how much time do I have left? I'm running short on time here. Okay, so I'm going to skip through the rest of this. Let's go down and actually see what some of the actual findings look like. I have it use both CVSS as well as just using a more business-friendly, in my opinion, rating of impact and likelihood, some sort of a severity just based on high, medium, low, or informational. I think that's more useful as a business person when you're trying to prioritize. Again, we're trying to partner, we're trying to build trust. I'm not going to throw technical jargon. Okay, so yeah, that's what findings look like. Has here a summary, and then at the very end, you can see here's the final report. This was surprisingly good, considering that I didn't go in and edit some of the outputs. If I can get to the top of this, very long file here. Again, this is, I released all of this under MIT, so go play with it, and please tell me what's wrong with it. I haven't gone in and tweaked and tuned anything yet, but if you have ideas for that, send a pull request. But yeah, it had 15 actual vulnerabilities ranging from critical to medium, and every single one of these vulnerabilities was legit. There were no false positives here. I was surprised because I didn't spend the time that I'm telling you to go do, by the way. I'm not telling you to just take it at face value, but I only edited like 2 of the stages going into this because I didn't have time. I just did this on Tuesday. I haven't had time to go in and tweak it further. But I was very, very pleased to see that the output was actually very, very good regardless. So here you can see where it's giving, in the executive summary here, it's using the business speak criticalities here instead of CVSS. But if you go into the actual vulnerability specifics, then you can get that CVSS if you want it. OK, so that's kind of the long and short of it. So with the last bit of time here, I'm going to go back to my presentation and try to get, where was the last slide? Where's that demo? Here we are. OK, so we're talking about code surveillance, right? That was in the title of the talk. So how do you make this continuous? Because we're talking about a point in time here. So what if we had the AI actually reanalyze things on every time you pushed code to the repo, right? You can build a hook. The main thing is that you want it to start at the top. If the threat model changes, if there's some new feature that's added that adds another use case that wasn't in the original, then you want it to start from whatever stage it was that, you know, all of that context changed, and then rerun everything afterwards. So it takes a little bit of tooling, takes a little bit of fiddling to get that right, but it's completely doable. And then once again, it identifies, hey, there's been a change in the business use case. We have a new attack surface that didn't exist before. I need a human to come in. I've done all of this work, and it's sitting here waiting for a human to come in and validate it before I move on. Again, The key is having the human review the deltas. And so this generates that loop where you're just taking the output, reviewing it, making sure it's correct. All of this is feeding back into the next iteration whenever it gets reviewed again. And this is what continuous AppSec, at least from the code review side of things, really should look like. So, closing thoughts, we're not replacing humans. We're evolving the way that we work in AppSec. We're evolving the way that we work as developers. We're evolving the way that we work as security practitioners. The goal is to make humans superhuman instead of just human. We're getting better tools. We're getting faster insights. We're getting broader visibility into our code bases. We still have to use our own judgment, our own creativity, and especially right now, our own ethical frameworks to manage what the output is coming from the AI. So if we use it right, then we'll spend less time chasing those low-risk bugs and more time solving the problems that actually affect security, that actually matter to us. And so I, for one, welcome our AI code review overlords. Just remember that we're the ones that approve those pull requests. All right, any questions? So if you want the link, if you don't trust the QR codes, it just takes you to that GitHub link right there. So any questions? No questions. Awesome.
More about your AI overlords.
Well, I'll tell you more about them when they introduce themselves. They haven't.
Yeah, they're already there.
They're hiding behind the scenes in the shadows still. But thank you all. Appreciate you coming.
Thank you all very much.